Question number 16. Calculate the value of x and y and give your answer to three significant figures. Okay, first of all, we'll try to find out the value of x using the triangle, this triangle over here, the triangle at the bottom. This is a right angle triangle, and we'll use this right angle triangle to find out the length of x. If we only consider that highlighted right angle triangle, we realize that we have the length of the two sides, hypotenuse and maybe opposite. And we can very easily find out the length of x using the Pythagoras theorem, according to which hypotenuse square is equals to base square plus perpendicular square. 41 square is going to be equal to 1681. This is 1681 is equals to x square. 9 square is going to be 81. So I'll move this 81 to this side. 1681 minus 81 is equals to x square. When I subtract 81 from 1681, I'm going to get 1600. So x square is going to be 1600. In order to find out the value of x, I'll take a square root on both the sides. This square can be cancelled with this one. This is x. Square root of 1600 is going to be 40. So this is going to be 40. And since I have to give my answer into three significant figures, so I'll say 40.0. Okay. Zeros at the end of a decimal are always significant. So I'll mention 40.0 and I'll also mention unit. Okay. Now that I have this value, which is 40, I'll think of finding out the value of y. If I look at y only, y is the length of a side of this triangle. Right now, we have no way of finding out the value of y in this kind of a triangle. Okay. So what we are going to do, we are going to consider the entire right angle triangle, this one. And we'll apply the Pythagoras theorem on that entire right angle triangle. According to right angle triangle's Pythagoras theorem, hypotenuse square, the hypotenuse of this entire right angle triangle is 50. So 50 square is equals to base square plus perpendicular square. After finding out the value of x, I know that the base is 40. So 40 square plus perpendicular is this. This is going to be y plus 9. So I'll say y plus 9 whole square. 50 square becomes 2500. 40 square becomes 1600 plus y plus 9 whole square. I'll expand this bracket using the first identity. According to first identity, a plus b square is equals to a square plus 2ab plus b square. One common mistake that students make while expanding this, they write y square plus 9 square only, which is definitely wrong. So you cannot write y square plus 9 square because a plus b whole square is equal to a square plus 2ab plus b square. A plus b whole square is not equal to a square plus b square. So I'll expand y plus 9 whole square using first identity, which will give me a square, which means y square, 2ab, which means 18y, b square, which means 9 square, that is going to be 81. Okay, what I'll do, I'll bring this 2500 to this side so that I get a quadratic equation in the standard form. 2500 is adding over here. When I move it to this side, it starts subtracting. So I'll arrange them all and I'll write them in the standard form. Y square plus 18y plus 1600 minus 2500 plus 81. All the constants at the end and equal to 0. This is going to be y square plus 18y, and this is going to be 2500 minus 1600 minus, okay, this is 819. So this will be minus 819 is equal to 0. Now that it's a quadratic equation, that is y square plus 18y minus 819, I can solve it using middle term breaking. I have to break 18y into 39y minus 21y minus 819 is equal to 0. So the first pair gives me y is common, so y plus 39. And in the next pair, I'll take minus 21 common, that will be y plus 39 again. So I'll have y plus 39 and I'll have y minus 21 is equal to 0. Now that I have two factors and their product is equal to 0, I can say any one of them can be equal to 0. So y plus 39 is 0, which means y is equals to minus 39. And I can say y minus 21 equals to 0, which is going to be y equals to 21. I'm getting two values of y. One of them is y equals to minus 39, and the other one is y is equals to 21. So which one of these two is the correct value? Let's have a look. If I say y is equal to 21, so this is going to be 21. So the overall length is going to be 21 plus 9, which is 30, which is definitely acceptable. Okay? And y itself is also 21, which is acceptable. But if you assume that y is minus 39, so first thing, can a length be negative? Definitely it's a no. Length cannot be negative. So y itself is negative, and if I look at the entire length, minus 39 plus 9, which is giving me minus 30. So I'll ignore this value because this is negative and the length cannot be negative, and we'll take y equals to 21 as our value of x.